Okay, so we're gonna start with page 4, the vocabulary first, because some of the vocabulary, we want to make sure that we're using the same terminology or the correct terminology. So the word translation means a slide transformation that results in a shift of a graph without changing its shape or orientation. Okay, so a slide, the word translation means it's just sliding left or right, up or down, but we're really not changing the shape of it. We're not making it stretched or compressed, and we're not flipping it. Okay, so that's what the translation is. Now I'm gonna write down something in here, and we're gonna spend a little bit of time discussing it right away. Y minus k equals the function x minus h. Okay. So that the word translation is just changing the value for k and the value of h. Now I'm gonna say this is what one of your fellow classmates said: y minus k, f times f of x minus h. We could also express it this way, right? Because when we look at our function, we have the y on its own, right? So what I'm gonna do is I can take the k to the other side of the equation, and what would that look like? It's gonna be y equals to the function x minus h plus k. Okay. I'm gonna stop there for a second, and then I'm actually gonna go all the way to the bottom. Is that okay? Or you're still writing it down? You're still writing it down. Okay, it's good? Yeah? Okay. So at the very bottom, I know it didn't have the word, but we're going to write down the word mapping. Because what we're going to do is we're going to use the mapping strategy to figure out the image after we've changed something, right? So a mapping is the relating of one set of points to another set of points so that each point in the original set corresponds to exactly 1 point on the image. Now you're probably thinking, what did I just write down? Okay, this doesn't make sense. Well, we'll see it right away. Okay. So mapping So let's just flip it in the next page. Did you finish or? Oh. 1 second. Okay, so here is a formal lesson. So lesson 1, horizontal and vertical translations. For a function y equals to f of x, okay. Now f of x, this is the general form. This is a general form. It could, the f of x, the function could be any function that you could think of, right? So a function, y equals to f of x, or for a function. A vertical translation is a function defined by the equation y minus k equals to f of x, where k is the number of units the graph is shifted vertically. So this k value, okay, this k value tells us the shifting vertically, the translation vertically up or down. And the reason why it's, I was like reading a different textbook and say like, why is it all in this form, it's on the left side? Why is it with the y? Because we wanted to specify and make sure that we understand that the k affects the y values. Okay? The k affects the y values. That's why it's y minus k. But it's still okay to bring the negative k, or the k, to the other side. Okay? So the k tells us the vertical translation. The vertical translation, either shifting up or shifting down. Now, for this one here, for a function y equals to f of x, and f of x is any function, okay? It could be cubic, it could be quadratic, it could be, you name it. Absolute value function, any function. A horizontal translation of the function is defined by y equals f of x minus h. Can you see that the horizontal translation is affecting the x? Horizontal is the x value. So it's with the x value. Where h is the number of units that the graph is shifted horizontally. So this h value is our horizontal translation. So we're not changing the graph. What we're doing is just moving it up or down, left or right. Okay? So K is positive, it's moved up. If K is negative, it's down. If H is positive, it's moved to the right, whatever is your right. And then if H is negative, it's moved to the left. Okay, so take a look at the example 1. So it's example 1. Here's a graph of y equals to g of x. Now you're probably thinking, oh, what graph is that? Okay, they're giving us a very different graph, a general graph, right? This is not one of our typical graphs that we've seen, but what we wanted to do is we wanted to sketch the image of the graph after each translation, write the equation of the image graph in terms of the function g, and then state the domain and range of each function. So we're going to start with the first one first. So it says here, translation 4 units up. So translating 4 units up. Okay, so what we're going to do is we're going to take every point and we're going to translate it 4 units up. Where would it go? Oh, sorry, left. To the left. Okay, turning it to the 4 units to the left. Okay, so every point has to be translated to the left. So this point translated to the left. 1, 2, 3, 4. No changes in the y. And then you look at this point in here, you go, okay, translate it 4 to the left. So 1, 2, 3, 4. And then this point here, translating it 4 to the left. 1, 2, 3, 4. And then this point up here, 1, 2, 3, 4. Okay. So what's the new image? What's a new image? What was that?
We only did the left translation.
Yeah, we're gonna do it for this one here. It's like for each. We're gonna do it individually, not together yet. Yeah, we will get to the point where we're gonna do two different things at once. Okay. Remember, we're taking a baby steps here, and don't take the baby steps for granted. Okay, so this. Okay, so the graph is just shifted to the left 4 units. So every point is shifted to the left. Now I only moved 4 points, but really what I'm gonna do is I'm just moving the 4 points. I don't have to move every single point because everything will just follow as we go. Okay? Good? Okay, so that's that part. This is the 4 units to the left. This is what it looks like now. Now we're gonna do the second one. Oh, before we do that part, okay? Before we do that part, I wanted to show something. The mapping. Okay. So get used to it right away. So when we go 4 units to the left, our mapping would be x minus 4 there's no movement on the y, so the y stays the same. Is that okay? So our xy, whatever xy before, this is the mapping that we're gonna do. We're moving the x, we're moving every point to the left, so it's gonna be x minus 4. Okay. So what would, this point here used to be -1, 1. Okay. And then this point here is 2, 3. This point here is 4, 1. And then this final point is 6, 6, 6. Okay. So 4 units to the left. So when we move it to the left, what happens to this? What's a new point? It's going to be negative. Yeah, we'll do this one first. So it's going to be -5, 1, right? -5, 1. This 2, 3, that's this point here. When it moved to the left 4 units, is now at -2, -2, 3. So whatever the -2 is, -4 is -2. The 3 stays put. What about the next one? It used to be 4, 1, because we've translated to the left. It's going to be 0, 1. And then this one here, it used to be 6, 6, 6. So now it's a 2, 6. Okay, so mapping it 4 units to the left. Okay. Now because 4 units to the left, that's the h value. H is equals to -4, right? H is equals to -4. 4 units to the left is a -4. So our equation y minus k equals to f of x minus h. So in the equation, there is no translation vertically, so it's going to be 0. So y minus 0, whatever that function is that creates this graph, f. X minus, the h is negative, so -4. So the function looks like y equals to f of x plus 4. Okay. X plus 4. So for a second. Oh, why is that value is 0? Because this is the only thing that we're doing right now. Translation of 4 units to the left. So there's no changes on the y. K is a vertical. Yeah.
Is it same as the A for the
Yeah, I'll talk about that when we get there. Okay. Is that okay? So far, so good? Yeah, okay. Baby steps. Now looking at this one here, what's the, say the domain and range of each function. What's the domain of the new function? -5 up to +2, including, right? So it's going to be square brackets, -5, comma, +2. That's our domain.
Why square brackets?
Why it's square brackets is because it's defined at that particular point. Yeah, and it's defined at 2. What's the range? +1 to 6. Yeah, including 1 and including 6. Okay? Good? So that's for number 1. So far so good. I'm gonna try number 2. It says here number 2 is a translation 1 unit up. Okay, 1 unit up, that's the K value. Okay, so unit up, so K must be equal to +1 because it's a unit up, it's +1. Is that okay? Yeah. So what are we gonna do? I'm gonna do the mapping and then we'll do the graph later. So here's the mapping for number 2. One unit up. So if x is -1, 1, this is the original points. 2, 3, 4, 1, 6, 6. Now because it's a mapping for y 1 unit up, the x stays the same, so x. And what's happening to the y? Because it's 1 up, it's going to be y plus 1 because it's 1 up. Okay? So if it's 1 up, the k is up 1. The x stays the same, so -1. What's the y? 2. The 2, 3 is now become 2, 4. Okay. 4, 1 is now become 4, 2. And then the 6, 6 is now become 6, 7. Okay? So 6, 7. Good? Okay, now let's go over here. Why don't we take the original function and then move everything up 1. Okay, so let's do that. I'm going to use a different pen. So original graph, original function, move 1 units up. So every point moved 1 up. Is everybody okay? Everything moved one up, so I'll give you a moment to do that graph. Is your graph same as mine? Everything moved up one? Okay. Now let's take a look at this one. This point is -1, -1, 2, just like the one that we had in here. Is that okay? Now this point is at 2, 4, 2, 4. This point is at 4, 2. And then the last one is 6, 7. So that one is 6, 7. So what's the equation? It's y minus k equals f of x minus h. What's our k value? K is positive 1. So 1 f x. What's our h value? 0. Okay. So if we can simplify that, that becomes y minus 1 equals f of x. So we can write it like that. Or if we bring it to the other side, y equals to f of x plus 1. And then that's a plus 1 that we see shifted up. Okay. Now, lastly, what's the domain and range of the new function? The domain of the new one would be from -1 up to 6. Okay. The range is now 2 to 7, including 2 and including 7. That's why we put a square bracket there. Okay. That's good. Yes. Bring it up a bit.